in this section, we actually it's an extension really of the last lesson that we did when we investigated factorials and permutations. And so this is kind of the second half of that lesson. It just would have been too big for one. So consider the following situation where a baseball coach is deciding between 5 players for his top 3 spots in a batting order. The top 3 spots tend to be pretty important because those players tend to get the most amount of opportunities in a game because there's 3 outs in an inning, and so worst case scenario would be all 3 of those players get out in the beginning, and then the 4th player wouldn't get to hit. So that's why the top 3 get to hit more often than any other players in the batting order. So it's kind of an important spot. How many different orders or arrangements or permutations, because order is important here, are there if there's 5 players to pick from and we're going to be picking 3? Well, we talked about this last time. This is a permutation. There's a couple ways to do it. You can think through, there's 3 spots, 5 for the first, 4 for the second, 3 for the third. 5 times 4 times 3, that's going to be 60. And we said, oh, hey, that's a permutation. We can use the permutation formula or the calculator. From 5, you're going to be picking 3, which means you do 5 factorial. You need to divide out the 2 that were not picked. That's going to be 60. Or if you just use the calculator and do, let's clear these out, 5 math over to probability, permute 3, 60. So if you use the calc, you're going to get the same thing. So a lot of different ways you can think through the scenario. You can use the permutation formula, or you just use the calculator. That's what we did last time. However, now we're going to consider a different scenario, kind of extending it. What if the coach doesn't really care the specific order that they are in, just that the 3 that he chose are the top 3? So let's say that he has narrowed it down from the 5. He's going to pick Angie, Beth, and Cora for the batting order. Well, how many different ways could each of those selection of 3 players have been chosen? Well, once those 3 people have been picked, there are 3 factorial different ways I could rearrange them, because there are 3 options for the first batter. It could be Angie, Beth, or Cora. Once the first one's been chosen, let's say it's Angie, then there's only 2 options for the second. Maybe it's either going to be Beth or Cora, and let's say that he selects Beth, and once it's Angie first and Beth second, it has to be Cora. So there are 6 different ways that I could have selected those 3 players, and that I essentially overcounted. So each combination of the 3 players that are chosen can be rearranged in 3 factorial, or 6 different ways. Therefore, out of the 60 possible original lineups, there are now only going to be 60 divided by 6, 10 different combinations if the order isn't important, just that they were selected. So we overcounted if order is no longer important. So 60 if order is important, but if order is not important, once those 3 have been chosen, there are 6 different ways that I could have rearranged them, and I would have originally counted those as all unique, but they're really not, because Angie, Beth, Cora is the same as Cora, Angie, Beth if order is not important, just that they were all selected. So I overcounted by a factor of 6, and 60 divided by 6 would tell me that there's only 10 different combinations of picking 3 batters in the top 3 out of 5 possibilities. So this type of mathematics is called a combination. A combination is when I'm selecting items and order is no longer important. It's a number of combinations of n objects, so n is the total, r is still how many we're picking. The difference here is, though, that order is not important. Just being selected is important. If you look at the formula, it's actually the exact same formula that we had for permutations. It's just you need to divide by how many ways you can rearrange those that were selected, because you overcounted by that factor. So recall in the last lesson we did P from n selecting r. That was n factorial over n minus r factorial. You'll notice that's the exact same thing we have going on here. Oops, I want a highlighter. It's the exact same thing as this. The only difference is I need to divide by an r factorial, because order is no longer important. I've overcounted. So you can actually think of the combination formula is the exact same. It's the permutation formula divided by r factorial, because you need to divide out the number of unique ways you could have rearranged those that were selected. So there's a little note here. Think about this. Why is the number of combinations always going to be less than the number of permutations? Well, there's a couple ways. Philosophically, if order is no longer important, then obviously you're not going to have as many unique rearrangements, because order being important is what gives you all the different possibilities. Mathematically, you see, because you're dividing by something, you're always going to have a smaller number for the combinations because you're dividing by something. Let's try some examples. So example number one, let's say 15 companies have applied for commercial time slots during the Super Bowl. How many different sets, or this is combinations, of companies can be selected if only 10 slots are available? Let's use the equation first, and then I'll show you where the formula is in the calculator. So in this case, n would be 15, r would be 10 because I'm selecting 10. The combination formula says it's from 15, I'm choosing 10 is usually how you'll hear this said. It's either combination 15-10 or 15 choose 10 is the more common way you'll hear this said, is equal to, now if I go up here, it's n factorial, so 15 factorial, divide by 15 minus r, so 15 minus 10 factorial, times the 10 factorial. So this would be 15 factorial divide by, so 15 factorial because there's 15 companies applying. 15 minus 10 is 5. Why do I need to divide by 5? Because if you're only picking 10, 5 do not get selected. So you need to divide out the 5 that were selected. That's why this occurs, because 5 are not being picked and you need to divide them out. Now you also need to divide by 10 factorial because the 10 that were picked, originally we were considering order being important, but order is not important. Just the fact that your commercial is going to play in the Super Bowl is going to be important. So I need to divide by 10 factorial because there's 10 factorial different ways I could rearrange the 10 companies that were selected in order to rearrange their time slots, but just being selected is important. So 15 factorial divide by 5 factorial times 10 factorial. If you use a calculator for this, you would do 15, you need to put parentheses around the numerator, it's a fraction, factorial, divide by, now the bottom, there were 5 that were not picked, so 5 factorial times, now there were 10 that were picked, but I need to divide out all of the unique ways I could rearrange them because order is not important, but I counted it as important at first. And it tells me there's 3,003 different ways I could select 10 companies out of the 15 that bid. To use the calculator for this, I'm just going to essentially type this in as we see it. In the calculator, you'll type in 15 first, you go over to math, same place we got permutation, except it's not option 2, it's option 3 now, it's a combination because order is not important. And there's the 3,003. So 15 choose 10 is 3,003. So 2 different ways to do it. If you do not have a graphing calculator, Desmos will do this for you. You go over to the keypad, go over to functions, it says in the stats column or menu, right there, combinations. 15 are applying, I'm choosing 10. If order is not important, there's 3,003 different combinations. Second example, let's say for a court case, so when a trial is going to be happening, people are going to go into the jury pool. Let's say that there's 30 prospective jurors. How many different ways can the panel of 12 jurors maybe be selected? Well, just being selected is important. That's why this is a combination. Order is not going to be important. So I'm just going to use the calculator's formula from now going forward since I know what it does. It would be 30, choose 12. You can also write this as the following. It's the same thing. It's just a different notation. So I go to the calculator, say 30 in the jury pool. 12 are going to be selected. Order is not important because just being selected is important. So still there's a lot. 8649. I think it was 3225. What is that? 86.5 million. Huge. Check this. Do it as a permutation though, and just notice. What it was 30 and then permute 12. Ask yourself, is this number going to be bigger or smaller? If you need to, pause it and think about this before I hit enter. It's going to be much, much bigger. That is 4.1 times 10 to the 16th. If order is important, you have many, many more possibilities. because you can rearrange them. And once you've changed one and just switched, just flip two of the slots, two of the people, it's a different arrangement. So that's why permutation is going to have many, many more possibilities. Going to provide a chance for you to try. So pause the video now. First one, just can you find 5 choose 5 using the formula? And then in question 2, let's say 12 students are applying for 3 scholarships. Obviously, no person can win more than one. How many ways can a scholarship be awarded if no preference is given? Or B, if one particular student must be awarded one of the scholarships? So I think there was a question in the book that asked about this. That's why we're trying question 2. So pause the video now, maybe give it 2 minutes to try, see how you do. Come back after everyone's had a chance to try. Okay, first one, 5 choose 5. If you use the formula, you're going to get 5 factorial over 0 factorial, because everyone got picked, so no one didn't get picked. And there's 5 factorial ways to rearrange them, so that's actually just going to be 1. That should make sense. If there's 5 things, how many ways can I pick 5 of them? I just pick them all, so there's only one way to do it. Calculator will tell you the same thing. Question number 2, 12 students are applying for 3 scholarships. How many ways can a scholarship be awarded if no preference is given? Well, this would be from 12, I'm picking 3. Order is not important, so it's just a combination. 12, math, 3. So 220 if no preference is given. However, what if one particular student must be awarded one of the scholarships? That's like saying going in that somebody's going to get one of them. That means there's only 11 people really applying for 2 of them. So it would be 11 choose 2. There's one less person applying because we know one of them's already got it. And there's also one less scholarship available. So now there'd be 55 different outcomes possible. Continuing on. Now what we're going to do is just practice looking at different scenarios. When is it going to be a combination? When is it going to be a permutation? So we use combinations when the order of the selection does not matter. We use permutations when the order does matter, which is kind of funny because we call these things combination locks, but really order is important because it's a password, so really those should be called a permutation lock. Example number 1. Let's say that you're going to have 13 songs in a playlist and you're going to pick 3 for the next few songs. So how many ways could you pick 3 songs from a list of 13? You could maybe argue that order is important. This one's kind of ambiguous. I think the book had this one. So if you said permutation, you'd have to make the claim that you think order is important. So most of the time it's pretty clear if order is important. If it's not, then make your case. I would say in this one, order is not important. It's just the fact that those 3 songs are going to be played is important, that they got selected to be played. So I think the book does it as a combination. So from 13, you're going to select 3. Just being selected to be played is the important aspect. So 13 choosing 3, 286 different possibilities for picking 3 songs from the list of 13. If you argued that order was important, you would do a permutation, and there's going to be a lot more if order is important then. It'd be 17, 16. So I think probably makes most sense to say order is not important in that one though. Let's say that you're going to select 4 side menu options from a total of 6. So maybe you're at a dinner and you're going to order some like appetizers. There's 6 appetizers to choose from. You're going to pick 4. Order is not important in this case. You couldn't even argue that one. So it's just the fact that they got chosen. The order in which they come out is not going to be important. They're all just going to come out. So this would be from 6, you're going to choose 4. So 6, choose 4 is going to be 15. There are 15 different combinations. The last one, there are 18 applicants for a CEO and vice CEO, so like president and vice president. Here, order is definitely important. The best applicant is probably going to be the CEO, and the second best applicant is going to be the vice CEO. Since order is important, this is a permutation. So anytime that they're doing like first, second, or third place or something like that, or president, vice president, CEO, vice CEO, that's a dead giveaway. It's a permutation because order is definitely important in that case. So 18 permute 2, 306 different permutations for that scenario. Gonna have you try, and then I think we have one last, yep, little clarifying part, and that's it. So I would like you to use your calculator to compute and then explain why each of these makes sense. So there's these are kind of special case ones. There's a pattern I want you to pick out with the last two. So pause the video now, use your calculator to compute. That's supposed to be the easy part. And then explain what the pattern is that's kind of going on, especially for the last two. So pause video now, maybe a minute and a half. Unpause it once you've had a chance to try. Okay, welcome back. If you type in 5, choose 0, it's going to be 1. The reason why is if there's a bucket of 5 things, there's 5 applicants, and you're going to pick 0 of them. How many ways can you pick 0 of them? Just one way. You don't pick any of them. So that one is 1. 6, choose 2. 6, choose 2 if you type it in the calculator is 15, and you actually did 6 choose 4 earlier. You should have seen it was also 15. So that, look at that. 6 choose 2 is 15 and 6 choose 4 is 15. Why does that have to be true? Because think about this. If I say that there are 6 applicants for a job, how many ways can I pick 2 of them? There's 15, because if I pick 2, how many did not get picked? That means 2 got picked and 4 not picked. That's the same as if the scenario I were picking 4 and not picking 2, because the universe mathematically has no difference between knowing picked and not picked, because there's no universal like good and bad. Maybe actually not being picked would be a better scenario. So these have to provide the same number, because it's just a matter of perspective. 2 picked and 4 not picked has to be the same as 4 picked and 2 not picked because of symmetry. So hopefully you kind of see the symmetry going on there. Last one, I want to clarify. Earlier I stated the following. I said combinations is going to be less than permutations, but there was actually an equal to case. So combinations will never be more than permutations. When is it the case that the number of combinations would be equal to the number of permutations? Here's a little hint. Ask yourself, how many items does there need to be in order for the order to be irrelevant? So pause the video now until you think you have it. Unpause it once you want to see what it is, because I'm about to tell you. Order would not be important if you're just picking 1 or 0 things. So those two are equal if you're picking 1 item or 0 items. If you only select 1 item, then it would be n. Because if you're picking 1 out of a set number of n things, you could pick each of them once. Same with this, it'd be n. And then the 0 cases would be, both of them would be 1. So C and choose 0 would be 1. P and choose 0 would be 1. So those are the cases when they're equal, when you're picking 1 thing or if you're picking 0 things. That is it. Thank you very much, and have a good day.